Welcome to another exciting episode here at Spain Park High School AP Chemistry. Today is Wednesday, February the 16th. Time just keeps on slipping into the future as we're trying to race through this AP curriculum, getting to the end so we can all make fives on the AP test. All right, so if you turn to page 7 in those beautiful color notes that I did not create. I was going to use a different term, but I remember that this is going to be on the internet here, so don't want to incriminate myself. All right.
What are the 10 viewers?
Yeah. Dinitrogen tetroxide in its liquid state was used as one of the fuels on the lunar lander for the NASA Apollo missions. Is that important for solving this problem?
No.
No, but it's very interesting. In the gas phase, it decomposes into gaseous nitrogen dioxide. Consider an experiment in which gaseous N2O4 was placed in a flask and allowed to reach equilibrium at a temperature where Kp equals 0.133. Okay, so we put stuff in. At equilibrium, the pressure of N2O4 was found to be 2.71. Calculate the equilibrium pressure of NO2. How do we do that? See if you can do that. 2 minutes. This is a relatively easy problem. Page 7.
Page 7. So you have to do like algebra stuff, right? It'll be fine. Here, it is. Okay. No, it's not.
It's GA2
Yeah. I don't know if I actually.
Come on, y'all.
Oh, sorry.
right there.
You just lost it, Sydney, as far as you can't find your notes.
No, I'm trying to find which problem we did yesterday that explains how to do this problem, so we've been so early. But I can't remember if it was in the notes or if it was a textbook problem.
It was, I just did them all pretty in. I did individual notes, the different types of chemical reactions, the equilibrium problems. Definitely need a calculator, but
We like that. We like that. We got the right answer. Partially because it gives you the right answer.
yeah. Well, you got to show how you got to that. Okay, hint. Write out your Kp expression.
I did it.
Was that 27?
All right, so there's your Kp expression, right?
Yes.
What do we know? I
I
know Kp is 0.133. It says at equilibrium, so I know I'm at equilibrium pressure. It's not an initial pressure, it's equilibrium, which we say we like that because that makes everything easier. The N2O4 was found to be 0.271, so we can say that 0.133 is equal to NO2, which is what the question is asking for, squared, divided by 2.71. So multiply both sides by 2.71, and then take the square root. NO2 turns out to equal Actually, the pressure, what did I do wrong? What did I do wrong with this drawing right here?
It's non-molarity.
It's not molarity, it needs to be pressure. Okay? So I'm starting off slow. So now it's not gonna change anything as far as calculations, it's just the setup. It's gonna be squared divided by the pressure of the N2O4. So this is not gonna be a bracket. This is gonna be the pressure of the NO2 squared. Same exact math, it's just how we represent it. Yes, sir, Matthew?
Okay,
So you solve for the pressure of the NO2, multiply the two sides, take the square root, the pressure of the NO2 is gonna equal what?
0.600.
And that's gonna be atmospheres. And you just know pressure is gonna be in atmospheres. We don't have to worry about the units. Okay? So, first thing I'm gonna do, if I'm given a KP, I wanna write out the KP expression. What do I know? What am I looking for? What might I still need to know to figure out what I'm looking for? And then you can kind of work backwards to say, okay, well, you can only have one variable, so if there's two things you don't know, there must be a way to figure out one of them. So you go back to the drawing board, you look at, well, how can I figure out that one? But in this case, there was only one thing that we didn't know, was the NO2. So I wrote out my KP knowing this, okay, so I know KP, I know the N2O4 because it says at equilibrium. So the only thing I don't know is this one. And then it's just math. Okay? So turn the page, as Bob Seger says. Any of y'all listen to classic rock?
I know that one.
Is it because of
No, it's because my mom.
that? Why is that? Why? You know who Lou Williams is?
You know what?
Lou Williams?
Okay, let's see what you can do with this one. This one's kind of like yesterday's. Okay, so this is where we start singing Ice, Ice, Baby. Dun, 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 dun.
Okay, so this one you get a little more than to follow. Is this no. This is the ice remember?
Now, I think in the notes they call it a rice table because they put reaction,
Well,
initial change, but I like Ice, Ice, Baby better than Rice, Rice.
Cake.
right, okay, so you look at the initial ones. You're gonna write it. Thank you.
If it's egg fried rice, then it's okay.
I'm down for some right now.
So I'm reading.
Okay, it's okay. I'm trying to find page. It's one meter.
So first you need this to be a.
Read carefully with the terms initially and at equilibrium.
But it's only in liters.
Yeah, we love it when it's in 1 liter.
So it just be ice.
They really run it to one sig fig.
No?
Or
I
PCL3.
see, I see,
PCL3 that does. I know.
I see 2.00.
And the concentration.
Let's see, chlorine is 35.5.
This is gonna be the change.
But you don't need that, it's already in moles.
Oh.
So the equilibrium is like, you're gonna put the two times the negative. I mean, you can put stuff, you're putting stuff up here, but.
Yeah, so Lily, I did post the videos from yesterday at 6:30 this morning because it finally posted to YouTube at somewhere around 3 or 4 in the morning. I know,
It's all-
so if you wanna go back, you know, your leisure time.
My 2 hour, that's what we do.
Yeah, you can watch it then,
Oh, yeah.
because it's gonna
We,
be 2 41 minute, well, 41 and 43 minute videos. But there's a lot of dead times we're solving problems in it that you can, not that you'd be watching at 1.5 or 2 times speed anyway, but you can fast forward through the dead spots. So it'll probably end up being a 20-minute video.
No, I'm okay.
That's what I'm talking about.
Okay.
I need to pay someone to go through and edit all my videos and take out all the dead spots. Then maybe I can get.
it's not that hard to edit, you can just use.
Anytime I try and edit it on there, and then I try to upload it on YouTube, it goes up royally. It goes all green on the video.
Oh, I know, I've got it. Oh, I'm stupid. Okay. So because the.
You're not stupid because you figured it out.
Yeah, I
You're
did.
smart.
I got there. So because it was like it made a mention of the CLT, you just put 0. And so now you have,
Why is it?
but that's at equilibrium. So that's not the initial one. So for the initial one, you're.
See, that's why we have to read carefully what we put in initially and where it gets to at equilibrium.
And so now you're gonna calculate the difference. You're supposed to calculate the difference between what you have initially and the concentration between the equilibrium. So to get from 0 to whatever that is, you're gonna have to like add 2 times and then your PCO, since there's a 1-to-1 ratio, you add 2 times.
Okay, go ahead. I watched the video.
So then the equilibrium concentration is gonna be 0.7. No, wait, it's actually that
A
line.
lot of it.
It's gonna be that.
Nothing right here. If you go to, well, here will be 7. Jeez, how many birthdays are there?
Yes.
And I got 8.96.
Okay, so I'm doing that right now. See, look.
Yeah, that's
So that's the final concentration. So what do you point? For some reason. I don't know, that's what it says. Oh, I see what it is.
I was looking at the shed.
The Shetty is.
Okay, cool. We'll go with point 3. So it's point 3 And then for the PCl4, since it's still a 1-to-1 ratio, but it's gonna be negative -2.
Dun, 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 dun. Hey.
Yeah. Okay. Yeah. We'll see how you roll it.
Oh, no.
What did you say? It is 6.7
What?
That's 8. And then, once you get all of that, you get to plug it into the fun little.
So does this end up being 6.7 times 10 minus 3?
Yeah.
Since they're both at the same power, I can just subtract them, right? So 6.7 times 10 to the minus 3. Okay, so there are your 3 equilibrium concentrations. This one is also plus the same amount, but I didn't write it because it's with a 0. They're all 1-to-1, so we're gonna lose this. If that's how much of this got made, it had to come from there.
Because, you know, the concentration, it's like, products times.
So now KC in the Sunshine Band is gonna equal
0.3, because that's the.
0.3 times 2.00 times 10 to the minus 3rd divided by, and they're all saying no exponents, 6.7 times 10 to the minus third. So what does that end up equaling?
8.96 times 10 to the negative second.
10 to the minus 2?
Yeah.
Okay, so does this mean that it's going to be reactant favored or product favored?
Reactant,
How do I know that?
because it's below.
Because it's less than 1. Reactant favored. What does that mean about delta G? Positive or negative? Positive delta G. And if you recall, we had that equation, delta G is equal to negative RT, the natural log of K.
Real, what? We didn't.
Okay, we talked about that just briefly with thermodynamics. That equation's on your equation sheet. It's the relationship between delta G and K. Now notice, if K is less than 1, what's the sign of the log gonna be? If K is less than 1, and we take this log of it, what sign is it gonna end up being? Negative. Okay? The log of a decimal is a negative number. So therefore, if it's negative and a negative, delta G is gonna be positive. So if K is less than 1, it's reactant favored, delta G is gonna be positive. If K is greater than 1, the log of K will be positive. Take the negative of that, delta G turns out to be negative. So that's just kind of a relationship between thermodynamically favorable versus your equilibrium constant telling us whether it's going to be reactant or product favored. Okay, it's all math. Again, you need to know logarithms.
So,
You take the log of a decimal, it's a negative number.
what if that was like a bigger number than the reactant favored?
It's not going to be. I mean, it's not, the sign is going to tell me, any number less than 1, the log of it's going to be a negative number. A negative is a positive, always. Any number greater than 1, the log is going to be a positive number.
So if
Take
R,
the negative of that, it's going to, delta G will be negative.
so if R was,
R is a constant.
R is a constant.
Temperature is going to remain constant. We're going to do this all at the same temperature. The only thing we're changing is the value of K.
So K overrules R and T.
R and T are constants. They're not changing. Doesn't matter how big or small R and T are. Okay? The sign is what determines the spontaneity. Negative delta G is spontaneous. Positive delta G is non-spontaneous. Okay. Let's just kind of keep going through the notes here. Let's keep filling out the notes since these will give you good things to study. Let's do this one. I think these are all the pages I skipped originally, weren't they?
Steve, react with Steve. I guess we can build equation. And hydrogen. Do we have to make our own equation?
Yes, but I'll help you with that. It says carbon monoxide reacts with steam to produce carbon dioxide and hydrogen, which is going to be H2. Pretty straightforward. Now, I'm going to assume that when they say calculate if 1 mole of each component is mixed, that's just going to be 1 mole of this and 1 mole of that, not 1 mole of everything. You're going to mix 1 mole of this and 1 mole of that in a 1 liter flask. So it's 1 molar. So So your initial is 1 molar and 1 molar. 0 and 0. Otherwise, we have to do a different step. Well, actually, that's not true. We may not be that, we're not gonna get the same answer. They did a different thing on this, but let's just go do it like this for right now. Then I'm gonna introduce how to do this. You may not be able to do it now. If it requires quadratic, just set it up.
Is the equilibrium constant like KC?
Yeah.
Yeah, it's because we're given molar, so it's gonna be Kc.
Oh, it's that.
Wow. Okay, so how do we make this non-quadratic?
Square root.
Square root, okay? So take the square root of both sides. So the square root of 5.10 is gonna equal x over 1 minus x. We can add in all our sig figs later. So what's the square root of 5.10? 2.26 times 1 minus x is equal to x. So 2.26x minus 2.26x equals x. Oh, 2.26 minus x. So add that, so 2.26 is equal to 3.26x divided by 3.26. X equals, and you get a number. Okay, so x is equal to 0.692. Is that what I heard?
Yeah, 0.693.
693 molar, which is going to be x, we let x equal these. CO2 equals H2. The concentration of the CO is going to equal the concentration of the H2O is going to equal 1 minus x, which is going to equal 0.307. All right, now that's would be if they just gave you 1 molar and 1 molar. But this problem, based upon the answers, didn't do that. I'll let you copy this down. Did everybody see what happened here? Initial concentration, 0 and 0. Since these are 0, the only way it can go is to the right. So some of it's gonna leave here, but however much reacts here, it's gonna form there. So my equilibrium concentrations are 1 minus x, 1 minus x, x and x. Then you just plug all those into my equilibrium expression and solve for x. Okay. So now, we're gonna do this an easy way and a hard way now. So we're gonna do 3 times. 1 time the wrong way, 2 times the way that they intended. Okay, because we're learning something new now. Okay, I just did, again, when you're solving here, I'm just plugging in for x. Matthew, 1 minus x was what we said the CO concentration was gonna be.
Why is it 1 minus that?
Because you start with 1, but x amount reacts.
Okay.
So at equilibrium, we're gonna have whatever x amount, 1 minus however much reacted. Well, we figured out how much reacted, 0.693. Because these were 0 and now they're 0.693. Okay. Oh, I should erase the equation. Leave that up, I think that's what you're saying. Okay, so now I have CO plus H2O goes to CO2 plus H2 gas. So if I put in 1 molar of everything, if I put in 1 molar of everything, some of it's gonna react. Well, I mean, it's not at equilibrium. These are my initial concentration. I'm just dumping this in here. What do I need to know? Which way the reaction goes. Is it gonna go left to right? Is it gonna go right to left? The simplest way to figure this out, because they're all equal concentrations, if I did products over reactants, what would K be? It's 1. It's 1 times 1 over 1 times 1. Everything's a 1. Right? But our equilibrium constant is a 5. So just by knowing it's greater than 1, what does that tell me is in terms of reactant or product favored? It's product favored. So I know it's got to go to the right. So it's going to be minus x and plus x. So we can just know by knowing it's 5.10. But the way that we do this, if it's not quite as easy numbers, is we have to do this thing called the reaction quotient Q. Q is the exact same thing as K. It's the ratio, it's just not at equilibrium. So you go in and you plug in and find the value of Q and compare it to K. Now our value of Q, we just did it. What's our value of Q if we plug in products over reactants? 1. Since 1 is less than 5, in order to make Q equal to K, in order to get to equilibrium, we gotta have a bigger value, which means I need more products and I need less reactants. So when all the reactants are given, when all of the concentrations are given of everything, and you know the value of K, it's gonna be a Q problem. Now I always tell students this, the hardest thing about a Q problem is recognizing that it's a Q problem, because they don't say anything about Q. The way you have to recognize it is they give you everything. You have to know what direction will the reaction go. That's a clue that it's a Q problem. Is it gonna go left to right? Is it gonna go right to left? How do I know? And so here we're gonna calculate Q. QC is gonna equal CO2 times H2. It's exactly the same as K, it's just not, you can use initial concentration. You don't use your equilibrium concentrations. So in this case, it's going to be 1.000 times 1.000 divided by 1.000 times 1.000. Q is going to equal 1.00. Are you impressed with my mental math? Are you double checking me to make sure I'm right? All right, now, because Q is greater than K, and this is given, This K was given, that's this K right there. Oh, pardon me, try this again. Q is less than K, 1 is less than 5, I'm sorry. 1 is less than 5. Because Q is less than 5, the reaction must go to the right to increase product concentration and decrease reactant concentration. Because it's a ratio of products over reactants, if I need Q to reach equilibrium, it's when Q equals K. So in order to get to equilibrium, Q's got to get bigger. So it finally equals the 5.1. It's got to go from 1 to 5.1 to get to equilibrium. So since it's products over reactants, the way you make Q bigger is you have more products and less reactants. If it's the opposite, if Q is greater than Kc, it's going to go the reverse. It's just a ratio of products over reactants. So we make Q bigger or smaller. So that way we now know, okay, I have all of that written there. So now in my ICE table, and if you guys are going to keep doing this, I'm going to rewrite my equation. So now I'm given 1 molar. It says you put 1 molar of everything in there. That's my initial. But because Q is greater than K, pardon me, Q is less than K, the reaction moves to the right. Y'all, is everybody, are you with me on that? It's called the reaction quotient, that's why they use Q. So that means my change is going to be minus X, plus X, and plus X. This is going to react to go to make this. These are going to go down, these are going to go up. So at equilibrium, I'm going to have I'm just going to take all my zeros out, I'll put them all in at the end. X and X. So, Kc is going to equal x squared over 1 minus x squared, which is going to equal my 5.10. So now again, we end up doing the exact same math we did before. And what do we get?
2.26 or 0.693
Okay.
for the X for X.
0.693. Is that what we get? Because they got 613. Oh, Steve, what did I do wrong? What did I do wrong?
I just got the right answer.
No.
1 plus X.
What are the products going to be? The products aren't going to be X. What are the products going to be? What did I start with? What was my initial?
Oh, yeah.
It's going to be 1 plus X. 1 plus X. So this is going to be 1 plus X squared. So we still take the square root. What's 5.10 square root?
That's 2.26.
2.26 is going to equal 1 plus X over 1 minus X. Now, unfortunately, then we've got to do some good algebra. Now, you have your fancy calculators. If you have your fancy calculator, this is a good time to learn how to use your solve function on your fancy calculator. And just plug it in. And you can even plug it in this form and get the value of X. But how do we do it algebraically?
Cross multiply.
2.26 times 1 minus X is equal to 1 plus X. So 2.26 minus 2.26x is equal to 1 plus x. Collect like terms, bring the 1 over here. 1.26 is equal to 3.26x. Divide both sides by 3.26. X equals
0.387.
That's 0.387. That's a little bit better. Are you just saying that based on that answer, or did you actually do it?
I did.
Okay. I just want to make sure that we're getting the same values. Okay? So now when we go back in here and we plug in 1 plus x, each of these are going to be 1.387 molar. Because I'm adding 1 plus x. These are all going to be 1 minus x, which is going to be 0.613. So, when you have to know what direction the equilibrium, so a lot of times the question will say, given these concentrations, put all for everything in the reaction, given these concentrations, is the system at equilibrium? Yes or no? If no, what direction must the equilibrium go? What direction must the reaction go to reach equilibrium? That's your clue that it's a Q problem. Whenever it says what direction does it have to go? The other way you know is when you're given everything. Yes, ma'am.
So, what's the difference between what we solved for first and this way?
Because we started with 0 the first time. 0 and 0.
So this way we were making it out to be the Q problem, but
Be-
the way that we first
be-
did it.
Was just a normal equilibrium problem.
Okay.
You're just putting the initial stuff in, and then you're having to find what, given the K, find what all your equilibrium concentrations are.
So they would clarify which way you're supposed to.
No, again, it's just you have to look. It's because we're given everything. That's how I know.
So why did we do it the first way?
Because I didn't think this was a Q problem to start with.
Okay. So,
And then I hadn't taught it yet, so I was going to try and just go ahead and make it like we were doing other problems.
okay, gotcha.
So now, remember that one sheet that I gave to you, that I said, oh, crud, we're not ready to do that yet.
Yeah.
Do you have this one?
Olivia really wanted to do this problem. She said that it was algebra. Yes. Yeah.
You want to talk to her?
Ah,
Are they out of town? Or are they just in town in something?
They're in Birmingham.
Hmm. Not quite Orlando, is it?
No, it's step down.
Oh, that's a pretty day today.
hey, you could go to Splash and Pinch too.
Although tomorrow they might get interrupted by a tornado or something.
Oh.
Are we gonna have early dismissal for tomorrow?
I don't know, who knows?
I think Barry was talking about having early dismissal.
Is it really gonna be that?
The news said to me, what I heard this morning, wasn't gonna get until like 6 o'clock, the bad weather. I
6
was
p.m.?
thinking- Yeah, I was thinking we might even have tennis practice. So, it's supposed to be like super windy, then that's horrible for tennis. All right, so now, let's read this. Knowing what we just learned, we look at this. Given the initial pressures, PCl5, 0.0500 atmospheres. PCl3, 0.150 atmospheres. And Cl2, 0.250 atmospheres. I have my Kp is given as 2.15.
So it goes to the right.
We can't be sure because it's not equal concentrations of everything. If it was equal concentrations, then we can kind of just figure it out. So because we're given everything, we don't know which way it's going to go. We have to figure it out. Thank God we have the technology. We have the ability, the mental capabilities, mental fortitude to be able to do this. So the first thing we have to do is find Q and compare it to K. So this is gonna be atmosphere, so it's gonna be QP. It's just like K. It's just, this is my initial concentrations. So I'm gonna leave room to do my ice table down, I'm gonna learn from the last time. QP is gonna equal 0.15, that's P, Steve, P. 0.150 atmospheres times 0.250 atmospheres divided by 0.500 atmospheres. So when you divide that out, what do we get for the value of Q? 0.75? Okay, we can do 3 sig figs, so I'm gonna say 0.750. So is that bigger or smaller than the given K? Since Q is less than K, the reaction will go which direction?
To the right.
To the right.
Be confident, Josh.
Okay? The reaction is gonna go to the right. So that simply tells me then, is this gonna be plus or minus X? This is gonna be minus X, my change. This is gonna be plus X and plus X. So the Q is gonna tell us which way the reaction is gonna go. Now, Q happened to turn out to be 2.15? What would that mean?
Oh,
It's already at equilibrium.
Don't we have to do
That would be
it?
so easy.
Yeah, let me say, it's not gonna go anywhere. It's there. Okay, so now it means my equilibrium is going to be 0.050 minus X, 0.150 plus X, and 0.250 plus X. So Kc is gonna equal 0.150 plus X times 0.250 plus X divided by 0.0500 minus X. All right? And all of that's gonna equal 2.15. Now, if you know your algebra,
calculator's good for me.
this is gonna be a quadratic equation, is that not correct? When you go ahead and, multiply those numerators, you're gonna get x squares as you, what do we call that, factoring, the binomial, whatever. Okay? You're never gonna have to use the quadratic equation, the best you have to do is set that up.
This is a mean problem.
Okay, K is too small. K is a ratio of products over reactants, just like K is.
Yeah.
Q is a ratio of products over reactants, just like K is. Since Q is less, that means to get to equilibrium, to make Q equal to K, you need a bigger numerator and a smaller denominator. You need more products, less reactants, so it's gonna go to the right.
So how is, Q is initial concentration.
Q is the concentration at anything other than equilibrium.
Got it.
K is only at equilibrium. Q is any other time. So then you have to figure out, well, if the reaction is going to go towards equilibrium, depending upon where we are, which way does it have to go to get there?
It's like a number one.
Yes.
Dude, bro, how do you?
Okay, so it would be nice if you have your fancy calculators, if you knew how to plug this into your fancy calculator. However, in college, they don't let you do that. There's a series of approximations that somehow you can go through and do, and you have to be able to do it without a fancy calculator. I think that's stupid. You know, just plug it in. As long as you know how to set it up, it doesn't really matter how to do the math. Okay? So, let's see you do number 2.
It's not a fun answer to those.
I have my TI-89s, but I can never remember all the parentheses and commas that you gotta put in.
Forgot to, they make it equal to 2.15, write the whole thing again.
It's the,
I'm gonna write tiny. What is the, molar mass of NO?
Well, it's 14 and 16, so it'll be 30.01.
Thank you, Hobbs. Science. I'm really proud of us.
Huh? You still on that?
Equal something.
We're at 2.5. What?
Okay, I know how to use this.
Did anybody use a fancy calculator and get an answer? What, here's that, did you know how to plug all that in? Did you get an answer? I gotta bring, I have my glasses on, read them out. So just put an X in.
Yes. Why do you have to do it with the writing?
Okay, so Alex did this, and X is equal to 0.027. Am I hearing that right? 272? Okay, now, you probably got two answers for X. But one of them was probably bigger or than 0.5, or it was a negative number, or it just wasn't rational. Because when you solve for X, you're gonna get two answers. But only one of them's gonna make sense. For instance, if you got a value that was bigger than 0.05, okay, you can't be that because you can't get a negative amount of a reactant. All right? If it came out to be a negative amount, you can't add a negative amount to a product over here.
Did you say that we're never gonna have to use quadratic?
Yes. But you will sometimes have to just show how to set it up. Especially in a multiple choice question, they could give you something like this and ask for what the setup would be.
Yeah.
Okay.
It's really interesting.
So again, on all of these, what do you need,
I
Josh?
still don't get how you got 0.027.
Yeah, like, where did
That's
you?
X.
That's X. She
I-
just,
I-
she just plugged it into this.
You use your calculator.
She used her calculator.
No, I'm talking about how you got that.
You divided by
Oh, we're doing number one?
No,
That was number one there, now we're doing number two.
Then why?
Because molarity is moles of pressure, so you take the moles and then you.
I haven't done anything on number two yet. I haven't talked about number two, period.
Oh. Oh, okay.
Um,
I know, right?
this is my initial, Josh.
Okay.
By finding Q being less than K,
Yes.
I know that the reaction is gonna go to the right,
Correct, yes.
which means that X amount of this is gonna react. And for every one of these that reacts, we get one of those and one of those.
Correct.
So this is minus X, this is gonna be plus X and plus X. So at equilibrium, we're gonna have 0.05 minus X, this plus X, this plus X. That's my equilibrium concentrations.
Yes.
So then it's a ratio of products over reactants. So I just plug those values in, and that's gonna equal the given KP, which really, again, I did it in terms of KC, it's KP. Then this is equal to that. Now that's using the quadratic equation to solve it, but Alex just put it into her calculator and solve for X.
So you're trying to solve for K, well, it's KC. So you put it in.
2,000 K.
I have 5 TI-89 calculators, if anybody needs a fancy calculator to use in class.
Might as well get guarantee. You're gonna lose the first one guaranteed.
I also,
What did you say? Might as well get guaranteed.
You did Carbonic calculator with that.
I also purchased just some of these basic ones for those of you that don't have calculators, you can't find them in your car. And so I have these now for you to use if need be.
Thank you, Hobbs.
Gavin,
Trying to be a good
why'd you
dad.
put your green card on the thing? Why'd you put your green card?
Again, you have to plug it in, you're never gonna have to do a quadratic
I'm
equation.
thinking it's gonna be x squared.
Well, I don't think your calculator, you have to have like an inspire or a,
This is
one
zero.
that has a solve
Zero
program.
divided
Hey, there's a lot of talking going on, I don't hear us working on number 2.
So the number.
You don't, you don't have to, that's what I'm saying, you just gotta know how to set it up.
Because it's K is positive.
Look, the video will explain.
It does not.
I know, I explained everything perfectly.
Yes, you do.
I understand it completely when I explain it, I don't know why you guys don't.
Okay, wait. Is this one 3.067?
Now is this one gonna be a Q problem?
No.
No.
It doesn't give us everything.
Yeah.
No, so this is gonna be just a normal one.
Yeah.
These are the ones I don't do.
You can do a Q problem, you can do this one.
I disagree.
Game on.
So you see here.
Did you get for X? Let me see what you got first. Oh, that's right. Squares. Smart man. That makes it easier.
Wait a second, I understand. Yeah, but.
So it's just,
Oh, wait.
2x.
No, I don't understand.
Wait, then we're multiplying it, so it's x squared.
You don't understand.
My grandpa had a word.
Right. Here, this is, how did I do this right? Because I came out with 300 x squared over 0.
It didn't
So,
list the
x
degree.
squared, I didn't have any idea what's going
I don't think I did it. Yeah. Oh yeah. You're right, Josh.
What did did I not hit a .61?
Oh, yeah.
That's what I got the first time when I did it wrong.
Oh, it is.
Got him.
Josh, is that your final answer? 0.006?
6, 7, 8.
What do you?
Golly.
I got what you got there.
So, wait, is the denominator when you solve for KC supposed to be squared too?
I think that's what, yeah.
So, yes.
You right, okay.
Yeah.
But the top of the square root is multiplying to
So then you just square root.
I right.
You
Alright, does everybody get to this point?
Yeah.
What's next?
I don't
What's my change gonna be?
The
What's-
change is gonna be.
Hold on, I'm after you.
Because it's positive A, it's going to.
Well, how much of this do we have over here?
Oh.
0. Can it go that way?
No.
If there's ever a 0 on either side, it's always gonna go towards the 0, because 0 can't react. So I know it's gonna go right, because these are zeros. So what's my change gonna be?
Minus X.
Minus
2x.
2x plus x plus x. So at equilibrium, then I'm gonna have 0.00678 minus 2x, x, and x. So 2400 is gonna equal x squared over 0.00678 minus 2x squared. So how can we get this to where it's not quadratic?
Square root.
Square root of both sides, solve for x. Now, if you have your fancy calculator, which you're allowed to use on the AP test, you just plug the whole thing into your fancy calculator. You don't even worry about taking the square root and doing all that. More than likely, you won't have one like this.
See, when did you get it this time?
What do you?
I actually correct.
Well, I just changed my answer.
Why did you change it?
Because I did minus x instead of minus 2.
Why would you? Ah.
Wait.
I gotta change my answer.
Wait,
Because there's two.
then why are we squaring?
Yeah.
Why are you squaring and doing minus one?
Because in our equilibrium expression, coefficients are raised to powers.
And,
Yes,
and the coefficients are also.
The coefficient is just for every two of these, we're gonna get one of those. 2 plays twice.
Yeah, you're right.
What'd you get from
Make it up.
Okay, I thought this was
The x and the 2x are the stoichiometry based upon the coefficients. The exponents are based upon your equilibrium expression. Yes, Josh?
So you square root that, like x squared, you square root 2 squared 400.
Yes, you got square root both sides. Y'all's math teachers need to tighten up.
I took regular math, and that was like those are the worst classes that I've ever taken. Regular math. Because the teachers don't really teach, they're just like,
Danny Spencer.
here you go, here's what I learned from other people. I don't really understand it, but you have a test on it.
Same now.
You're throwing some shade, it's been so cute.
See, all day you've been very aggressive.
Yeah. I was against Parker, so Vernon knew it was library, and now.
We're not trying to so Sydney shuts. So this guy looks confused.
It's just divided by 2.
See, I meant to be helpful, it just came out. You're just done with people today.
Okay, what did you all get?
That's all you have to stop ready.
Stressing
it out.
City. You took out 6, we took 6. That's really interesting.
What did you get?
Me and Rohan got
98.
0.00334.
Yes.
96.
Vindicated.
336.
Oh, how did I get this?
So-
Look at this.
Well, because Sydney, you did 99 by 433, which you should have done. 99. Why are you using 99?
That makes sense.
Why are you using 99?
Because that's
It's
what it is.
48 times 2.
It's 98, but then,
No, 48 times 2 is 96. And then plus 1 is 96.
no, it's 49.
Okay, I gotta use side to.
Because it's 48.99.
Oh, I talked to the negative.
So then it'll be 96, 90 what?
What'd you write down? I don't know if I scored it.
99.
Those are small numbers.
Oh.
Divided by 99.
Square that.
Why are you squaring? How do you just square it right here? With the equilibrium.
Oh no, it's 2x. Why did I do that
I
here?
can confirm that.
You put the
Can
twos
confirm.
in
See,
there.
I'm good.
Oh.
No. Watch this. Get it
I was about to clearly story hungry. Oh wait, we didn't even do the problem. Oh, we just find X and get that.
Did you get 1? Rob.
I'm never getting in my car and just like, I'm gonna do
Yeah,
That's literally all you have to do.
It's 0.00678 minus 2 times x. He got 1 times 10 minus
1 times 10 to the 1, 2, 3, 4th or 5th?
Well, he rounded it to 1 times 10 to the negative 4.
That's why.
1 time, he rounded that up to 1 times 10, okay.
Yeah.
I don't know what Hobbs did. I don't know what
I just did algebra.
Hang on.
Hold on, no, I got that 7 though.
This goes to here.
Wait, I did not get that.
48.99 times this equals 0.332.
Okay.
And then 48.99 times 2 is equal to 97.98. X is equal to X.
See, my answer's
I
exactly
got-
the same.
I think my calculator's automatically rounds it up.
Yeah, cause I got 49.99, so I just rounded up to 40.
I got
Round
up to
6
49
times
point
10
eight.
negative.
Yeah, I rounded up to 40.
48.99 times 2.
It rounds it automatically up. when you
Yes.
do it.
48.99 times 2 equals 97.98.
But
That's basically 90, and then you move to the right, it's 99.
Then when you move, yeah, so then it's this X, so then you put it to the side, so you're adding 1 to it. So it's 98.98. Then you divide by the 98.98 into the 0.332, and you get 0.00336.
oh, I see what it did. Okay, see, I forgot to add the 2 in front of when you're subtracting it.
Yeah. See, I took Algebra 1 in 9th grade, which would have been 1976.
I took it in 8th grade.
1 year after my parents were born.
Okay, I'm confused.
Which means, it's been a long time, but I still know how to do it. You guys are fresh.
You do this every year though.
You just did it. You're still in math.
Uh-oh, low battery.
Wait,
Oh, I think I closed it.
Wait, how did you get 4 zeros?
How did I get what?
4 zeros?
I got 4.
Yeah, I got 4 zeros.
Okay.
Yeah, I got 4 zeros.
This one here?
So they're just doing it wrong.
You just plug in 0.
It's 1, 2, 3, 4. I get point on this. I get 0.000. I get 671 is when I do that one. So then when I subtract the 671, I'm just down to the 7 out here. Are you getting 1 times 10 with 4 zeros? Are you getting a 1? I did this one in my head, so that one might be
I'm
wrong.
just getting it, but like with 3 zeros instead of 4.
No, you did it right.
I did it right?
Yeah, you do.
Although mine's a 6 at the end instead of a 7, but.
Yeah, mine's a 6 too.
That's a 8.
Ron's an 8.
Well, yeah, I guess it would.
Thanks, Rohan.
Well, I didn't see what happens is I didn't erase stuff off my phone and off my calculator, and so I carried out all the extra digits because I wasn't re-typing it in. So I think it just kind of carried out. So because if we do this, this is definitely going to come out to 72. So it would be the 6. But you get that far, you show your work. It's all good.
We're all really happy right now.
All right.
Break time.
No. This whole class has been a break.
An hour and
What are you
3
waiting
minutes.
Stop doing math.
We haven't really had any kind of focus. Okay, last problem right here, number 3.
No, focus.
We have not stopped working.
Well, why would we stop working? We're here, we might as well work.
He's changing his answer.
Who's changing his answer? I didn't
You're
change.
giving us different reasons. Like the reasons are contradicting each other.
Oh, and why we should keep working?
Yes.
Oh, we're gonna keep working because I say so.
I guess you're the ultimate authority.
That's the old parent answer, because I say so. Because I love it. I don't want to stop.
Is that true?
I only got a few years left to be able to do this. I gotta make the best of every moment.
You sure?
Well, yeah, I'm not sure that I have tomorrow to do it, but right now I'm planning on at least 2 more years. Hopefully, I really need to do 8 more years, but I don't know if I got that many.
What do you feel? How do you feel about the proposed schedule that?
I haven't seen a proposed schedule.
What's the
I'm always the
proposed
last
schedule?
one. How do you
They
see a
don't
proposed
show it.
schedule?
We don't see a proposed schedule. We just have inside sources.
What's the inside source?
So,
Who?
one of the
Who?
ones they're
Where?
talking
And
about
address.
is instead of having AO have like a study hall, but like you choose your study hall teacher. So like if you wanted to do AP
Just
Chem
AO.
2 periods, you could force the students to take your study hall and then have that second period of AP Chem.
Well, I don't like that.
Then there'll be teachers with like
Go talk to our
6
insider.
students who want.
So in other words, you're gonna sign up, now a lot of schools do the study hall through lunch.
Hmm?
You can do the study hall in conjunction with lunch. In other words, half the period is lunch, the other half is study hall.
My connection is
Well, we don't have to.
No, like,
Well, that would give you like, a little bit, it actually give you 30 minutes, you'd be, well, it's a 50 minute, it'd be 25 minutes.
That's what we did
lunch.
last year. Last year was like that.
Well, so if you had lunch in the middle of the class. Okay, let's do this. Once again, now let's read this one. 0.035 moles SO2, 0.5 moles of SO2 CO2, 0.08 moles of CO are all combined in a 5-liter flask and allowed to react, and you're given KC.
It's a Q.
You know everything. They're giving you all the reactants and products.
How do you know for sure?
That's a good go up. You
No.
gotta make sure.
no, just
Stop touching them.
Just don't think about it.
You gotta make sure. What do you mean make sure?
Like calculating Q.
No, you don't know for sure.
Just tell me what you want.
I'm telling you, I calculated first. Q is 2.28.
Don't spoil it.
Oh, sorry guys.
I did not get that.
That's not in agreement with back row.
Who's back row?
What did you
Me.
do? What did
I
you do?
represent all of Becker. You're just the
Oh,
last.
yeah, I did not get two.
I got
I did not
5.6.
get
I got 0.00112.
Yeah, I got that too.
I got 20.
You get 20?
What did you?
I got a
No,
No,
hey,
no, no, no.
listen,
I
hey, listen,
see
wait,
what
wait,
you're
wait,
wrong.
wait. I have a feeling I understand part of the mistake. You have this many moles of each thing, but what
I got
volume
this.
is it in?
It's in 5 liters.
5
You have
liters.
to calculate
No,
the
I just
liter.
didn't-
So you have to do it in molarity, you gotta divide everything by 5.
I got the same one as hers.
Okay.
Yeah, I got the same thing too.
0.00112 is.
You got 2 point something.
No! I just did multiply by 0.1. That's it. I just forgot to.
Alright, so we've all figured out how to do Q.
Yeah.
That's the easy part. That's the
Okay,
easy part.
Isha, you with us on this?
It's the easy part.
Okay.
So that means it's gonna go to the right. Right? No, yeah.
Is it less than or greater than K?
Less.
Okay, it's gonna go to the right.
Do I have to
Are
write
you
that
sure it's less?
down, or can I just know it? Like,
You show the work, if you show the work,
K
you
is
do the minus.
0.078 though.
I'm,
That's what it says.
yeah, I know.
But Q is greater than.
It's less than.
What, eh?
There are 2 zeros in the Q and 1 0.
Oh, you just have 2 zeros in the Q.
Do you not?
No, I do not have 2 zeros. I have 0 zeros in the Q. 0.229.
So anyway, if I was doing this for response,
What's
I have to write
70.9?
No, just do, solve for Q, then you can just, all you can do is say Q is less than K, and then just do your X's, show your ice table, then it's obvious which way you're saying it's going.
Oh, well, that's the problem. When you mix up the numbers, which, yeah.
So,
Yeah, I see it.
you're gonna, since it goes to the right, either gonna be plus X plus X. Equilibrium is what you're trying to find.
That makes sense though.
You have 2 zeros and 1 112.
Yes.
Okay. Oh, so you were wrong. I told you.
Recycle.
What?
What did you mean?
To recycle, wrong level.
Oh, right.
Scored for the other two.
You already know that. No, if it's less than, if it's K is less than, then it's way less. If K is greater than, it's
Oh,
probably.
yeah,
I am
no,
not
wait,
about to
no, wait,
factor
he
this.
said, if it's a quadratic, you just show how it says it. skip to the next problem.
Yeah, so what, just keep the.
Here, let's see if we can figure out how to
No,
work my
K is
calculator.
wrong. If you go by K, it goes left.
Summon the what?
Solve function. There's a way to like summon it.
There's a solve function and you go to your menu.
I like
It
this.
doesn't work.
Yes, it does.
It does.
I've tried it.
What?
It says too few arguments.
Yeah, you have to put in,
You have to put a comma.
Comma and
what you
X.
wanna solve for.
Ah, who does that?
Me?
anybody that does it.
Why would anybody put comma X?
Because that's the way the directions say.
Keep in mind you're dealing with a computer.
It needs to have
You don't
brain.
understand.
It needs to understand.
Yeah.
Can't wait till we have AI and then AI can do all of the tests for us.
People in
And then it takes
The
it-
AI is gonna look
fourth-year
back
government
and
say
say
you
you
augment
argued
reality.
No way. Comma X.
You did it?
Works.
So what I do here, I do comma
No,
X.
look at that.
No, you
Oh,
type
oh,
it in and then you do comma.
Now, what am I doing wrong if I'm getting .229?
You're
For
probably.
Q.
One is on the bottom.
Yes, but.
Oh, it's because they mixed it in the middle. That's
Yeah,
why.
I know, I hate that. That's what. So
And the
weird.
point, point zero
Yeah,
zero.
yeah, there's just reverse.
You're in good company.
Aren't you glad every mistake we're making is now on Hobbs' video that he's gonna?
I know, I'm gonna delete it, I'm gonna edit. Sorry, y'all, you don't get to watch this video. It cut off somehow or other at 1:15.
Oh, I didn't upload properly, oops.
Yeah.
Did you see the clock?
Oh my god, I got two problems and two answers.
That's good.
Okay, you're always gonna get two answers, so only one of them's gonna be realistic, so what are your two answers?
Negative 0.152.
Okay, so you cannot have a negative amount being added,
Okay,
then
then
it's gonna be the only positive.
there's 0.05.
Okay, so that's gonna be your value of X.
What? Oh, you've already done that.
Yeah, he just did on his calculator.
Why is so many
Yeah, I don't know why they have.
No, it's your sentence.
What's good? The more decimals, the better.
No, it's not.
Of course, you need
Accuracy.
if you yeah, it's accuracy. What? What you want? You want 0.9 of a dollar?
There's 90 cents.
Or do you want?
No, it's one.
For AP only ever
0.9
gives us the problems like 3
One
sig
sig
figs, they
fig.
should give us a problem like 10 sig figs.
Oh, what do you think, results?
Okay, now I understand what we've done here. We copy it.
Records.
For what?
Okay. So the hardest part is finding Q. Okay, now listen, I made a mistake. The way you can fix your mistake, keep from doing what I did, is as you solve for the concentration, put it above the substance that you're finding it for. Because they didn't go left to right with their information, okay, I messed up because I put these two as products and this one as a reactant. But the reality is that the numbers were switched. So if as you go through, SO2 is 0.007, then when you plug it into your equilibrium expression, you're probably gonna plug it in more correctly than what I did.
Only AP would do that.
All right, I don't know if this was an AP question or not, it might be one I made up. Actually, I probably copied it out of somewhere. So, since Q is less than K, we know it's gonna go to the right, which means that this is gonna be minus X, plus X, and plus X. So at equilibrium, we're gonna have 0.10 minus X, 0.0070 plus X, and 0.016 plus X. So then you plug that into your KC, which is gonna equal 0.078. It's gonna equal the two products, 0.0070 times 0.016 divided by 0.1. Steve, oh, boy. Try this again. I was putting initial. Go with equilibrium of 0.0070 plus x, 0.016 plus x, divided by 0.1 minus x. Now, that's as far as you're gonna have to go. You are not gonna have to do quadratic equation for me or on the AP test. Everybody cannot afford a fancy calculator that can do the solve function, the Inspire and those. So you're never gonna be expected to do a quadratic equation. College, you might be, but here, for me, in an AP test, you're not. So, but when you plug it in, what did you end up getting?
X is equal to 0.051.
Okay? Now, what was your other value? Do you still have it?
It was negative 0.152.
Negative 0.152.
Uh,
Okay? So your calculator is going to give you those two answers. But you cannot add a negative amount. If it's going to the right, you're not going to subtract x. So I know that my negative one is not a valid answer. Only one of them is going to be valid. And so you just got to figure that out. Sometimes it turns out to where x would be greater than 0.1. They'd both be positive, but x is greater than 0.1. Well, you can't end up having a negative value here, so that would be an invalid answer as well. Now, once you get the value of x, then you just plug it in and solve for each of your concentrations. All right?
Sit down with Carson's
Don't open it.
oh, damn it.
We'll give that.
Okay, so we should be able to do equilibrium expression. We should be able to find Kc given concentrations. And that's where we had the three types of problems. We're either going to be given the concentration in equilibrium, which is rare. We're going to be given an initial concentration in one of our concentrations at equilibrium. In essence, they're giving us the x. They're giving us what the change is. Or they do a percent reacted, which again is giving us the x, how much reacted. Okay? Or, on the other hand, you're given K and you have to find your equilibrium concentrations. And then, if that's the case, then you have to make sure, if everything's given, you have to solve for Q, the reaction quotient. And the reaction quotient is going to come into play in this next part that we're going to go and do. But this basically is the end of chapter 15. All right? We're going to go and we're going to do the last half of chapter 17, which is going to deal with what's called solubility product, KSP. Now, the plan is that today is Wednesday. I'm going to get into that tomorrow. All right? I hope to get it all done tomorrow. But there's 5 types of KSP problems. 4 or 5. 5 types. 5 types of KSP problems.
So this is just
The first 3 are for sure you need to know how to do for AP. The 4th one is if, I can't ever remember if it is or not. And the 5th one for sure is not, but I'll make it a bonus on the test. Okay, because you need to know how to do it for college, and that's what our lab is going to be about. So that's Thursday, Friday, practicing all that. I really want to do a lab on Friday. And then Monday, or not here Monday, Tuesday.
We're not gonna be Tuesday.
I just said.
Oh.
Okay, so Wednesday, kind of reviewing lab, reviewing problems, maybe even a review Thursday test like Friday.
That's valid.
Projects are due a week from Thursday, a week from tomorrow. So you have a week. Okay, if you need poster, your poster boards, I gave most of y'all poster boards, but if you need.
model, you want
Model?
model you win.
Oh.
Model UN was not there.
Rohan already got his though.
Sorry. Okay, so, and again, remember, I am eliminating the Google Slide requirement. So you'll just present off your poster. Now your poster is going to be highlights. Your poster is going to be bulleted highlights, but you're going to need to be able to expound on those when you do your 1 to 2 minute presentation.
Are we just gonna stand up there and hold our poster, or are we gonna put on
You're going to just stand there and hold your poster.
Just the ones.
so it's gotta be big.
Big enough to see, but I mean, there's, you know, the poster's not that big though, so you know. But you can also, you know, don't just read off the poster, because that's boring.
So you're gonna have a picture of them, why we picked them, and then cool facts about them?
Yes.
Like what they did?
Yes, that's pretty much it.
But then when we present, we have to go off script.
Just go a little off script, you just give me, you know, fill in the, you know, some cool details.
Alright.
I've had this
And the
really
biggest
cool-
thing I want you to share when you do the presentation is why you chose the person.
Alright.
What it is about that person that inspired you, that brought them to your attention, that, you know, when you're going through the internet and you're just trying to search for somebody, what made them stick out? Or if you happen to know somebody, and you know, or an athlete or a performer, or
I need to
hey, it can
see
even
those.
be somebody here in town. It could be a preacher. It can be just a mentor. You know, anybody. Doesn't have to be a famous person. Just okay. Did you stop it? Bye.